Good morning all. I'm Dr. Gayathri, working as Assistant Professor in the Department of Chemistry in SNS College of Engineering. Today I'm going to share about the instrumental method of analysis, especially in conductometric titration. Conductometric methods. It is an electrochemical method of analysis concerned with electrical conductance through an electrolyte solution. It is defined for the determination or measurement of the electrical conductance of an electrolyte by the means of conductometer. Here the conductivity cell is there. In that, the electrical conductivity of the electrolyte solution, which almost depends upon the types of ions, that is cations, anions, or both cations and anions present in the solution, and the concentration of the ions. And the next, temperature. The mobility of ions. In conductometric titration, the main principle is that it is based on the conductance of electrical current through electrolyte solution, which is similar to the metallic conductors. The electrical conductance in accordance with Ohm's law, which states that the strength of current passing through conductor is directly proportional to the potential difference and inversely to resistance, that is I equal to V by R. V is potential difference and R is resistance. In conductance, which current flows per unit area of conductor per unit potential applied, and it is reciprocal to resistance, that is here G equal to I by R, and that is conductometer, and this is conductivity cell. In the left, the conductivity meter setup, and in the right side the conductivity cell. Instrumentation. The instrument used for the measurement of conductance are known as conductometers. It consists of current source, conductivity cell, and electrode. When electric potential is applied across electrode, two processes occurs. Ion accumulate near the electrode, transfer of charge through interference. The both process taken place. Here the DC current is not employed in the conductance measurement because the electrode becomes polarized, which leads to high cell resistance. The conductivity cell made up of pyrox or quartz, and it is fitted with two platinum electrodes, should be placed in vessel containing water to maintain constant temperature. The types: wide mouthed cell, the cell of reaction producing precipitation, and dip type cells. Electrodes: platinum sheets, each of 1 centimeter, are fixed of distance 1 centimeter. The surface is coated with platinum back to avoid polarization effects and increase the effect surface areas. The platinization of electrodes is done by coating solution of 3% chloroplatinic acid and lead acetate onto it to give a uniform coating. The electrode usage depends on conductivity and concentration. If concentration is low, then the electrodes should be largely and closely packed. And measurement. The instrument used to measure conductance is called conductance bridge or conductometer. The classical circuit employed for measurement in Wheatstone bridge. Other work on this principle. The conductometric titration, the process of qualitative chemical analysis in which the concentration sample is determined, which is done by adding a reagent, that is titrant, of known concentration in measured volumes to the sample. The reagent which is almost taken in the burette, and the unknown solution we have to taken in the beaker. We have to pipette out and taken in the burette. The types of conductometric titration is acid base or neutral titration, replacement or displacement titration, redox titration. One of the redox titration example is potentiometric titration. And precipitation titration, the conductometric titration with barium chloride and sodium sulfate is the best example for precipitation titration. Here that the barium sulfate precipitate got settled during the titration, and complexometric titration and non-aqueous titrations. Strong acid versus strong base, that is HCl versus sodium hydroxide. Strong acid and weak base, HCl versus ammonium hydroxide. Weak acid, strong base, acetic acid versus sodium hydroxide. Weak acid, weak base, acetic acid versus ammonium hydroxide. And advantages of the conductometric titration, which does not acquire indicators since the change in conductance is measured by conductometer itself. In the normal titration, that is in the volumetric titration, we require indicator for the through color change we can identify the end point, but in this case the conductometric titration, it doesn't require the indicator. The change happens in which can be identified through graph plotting, and suitable for color solutions too. In the case of volumetric titration, also the color solution can in the color solution the end point cannot be accurately measured. Since endpoint is determined through graphical means, which is accurate results are obtained with minimum error, used for analysis for turbid suspensions, weak acid, weak base, mixture of weak acid and weak strong acid. And disadvantages, the increased level of salts in solution masks the conductivity changes. In such cases, it does not give accurate result. That in the case of barium chloride, we get the some salts can be precipitated in and also accumulated in the conductivity cell. In that case, some of the result can be not accurate, not such accurate. So that case it fails. And the application of the conductometric titration to redox systems is limited because the high concentration of the hydronium ion in the solution, which tends to mask the change in the conductance. So these are the disadvantages of conductometric titration. And application oriented, we can check the water pollution in rivers and lakes, alkalinity of fresh water, salinity of sea water, deuterium ion concentration, food microbiology by tracing microorganisms, tracing antibiotics, estimate ash content in the sugar juices, purity of distilled and deionized water, solubility of sparingly soluble salt like silver chloride, barium sulfate can be detected, determination of atmospheric sulfur dioxide, estimation of vanillin in vanilla flavor. These are the day-to-day life applications using conductometric titration. Conductometric titration. For example, we can take the strong acid versus strong base. The graph, we obtain the graph like this. A decrease happens and increase happens. This is the rough graph for the conductometric titration of strong acid versus strong base. And strong acid, weak base, that is HCl versus ammonium hydroxide. Here sudden slight decrease and slight increase. And weak acid versus strong base, here very slight decrease and sudden increase. Weak acid versus weak base, that is acetic acid versus ammonium hydroxide, slight decrease and slight increase. Thank you.